Okay, in this video, we're going to have a look at defining our circular functions. So they're sine, cosine, and tangent. Okay, in our last video, we got introduced to the idea of the unit circle, and that appears again here so that we can define those three functions. So what we've got here, we've got our unit circle. Okay, we've got the coordinates of our points of intersection here. Okay, remember the unit circle has a radius of 1. Okay, so we're looking at a point here, the point xy, to some point on the curve of our circle here. Okay, we know that our line joining the origin to that point is going to have a length of 1 because the radius is 1, and it's going to make an angle of theta, okay, from the positive x-axis. Okay, so we can see then that this section here is going to be our x value, okay, and this section here is our y value. Now, if we think of SOHCAHTOA, okay, from our year 9 and 10 maths, okay, remember sine is opposite over hypotenuse. Okay, so if we look here at this triangle, because this is right angle, don't forget, that's a right angle down here, okay, and our angle's here, so don't forget, so when we look at SOHCAHTOA, it's opposite, which is this side here, okay, over hypotenuse, which is here. Okay, so what we find is that this, okay, is actually defined as sine. Okay, this side here is going to be sine from that SOHCAHTOA, and really that's our y. So here we can see that y is actually equal to sine theta. Okay, and similarly we can use SOHCAHTOA for here, this one here, that's going to be our adjacent, and our hypotenuse gives us cos. Okay, so we can define x being cos theta. Okay, so we now defined x being cos theta and y being sine theta. Now that works for any point on the unit circle. Okay, and that's going to be important because we've got these defined points here, which we'll talk about in a little bit. Okay, tan's a little bit different. So the idea with tan is that we've drawn a tangent to our circle, okay, and we extend this line, this radius, out, okay, to meet it over here. Okay, and tan is defined, okay, as this length here, okay, from the positive x-axis up to this point of intersection. Okay, and what we find from that, okay, is, remember, tan is opposite over adjacent. Okay, so that would be this side over this side. Okay, but we can actually use similar triangles because this side is sine theta and this side is cos theta. Okay, and this angle hasn't changed for this triangle. We can use similar triangles. What we find is that tan theta is actually equal to sine theta on cos theta. Okay, really important identity. Okay, one of the first that we come across. So tan theta is actually equal to sine theta on cos theta. Okay, and we'll see why. You may have seen graphs of sine, cos, and tan before. And we'll see a little bit later on why tan theta looks so much different. Okay, and why there's some points where it's actually not defined. Okay, so this means that for any point, okay, xy, okay, on the unit circle, the x value is given by cos theta and the y value is given by sine theta. Okay, that's really important. Now, if we have a look here, okay, I've sort of kind of drawn the unit circles again, kind of, but just reminding you of how far we get around for each of our angles. Okay, so I've got that one out a little bit. So we start here at the positive x-axis and we come around here to the positive y-axis, that's pi on 2 radians. We come around this far, half a circle, that's pi. 3/4 of our circle, okay, gives us 3 pi on 2. If we go all the way around, it's 2 pi. Okay, and you'll see why this is important shortly. And again, we can go actually the other way, so we can actually look at negative angles. So if we start at the positive y but come clockwise, then this is negative pi on 2, negative pi, negative 3 pi on 2, and negative 2 pi. Okay. Now, why is this important? It's important because we can actually define what our sine and cos are going to be at different points. Okay, so if we were to look at, say, cos of pi on 2, okay, we want to know what that is. Okay, well, we've measured a positive angle, so we're coming from here around. Okay, so we're pi on 2, so we're up here. Okay, now remember, cos is our x value. So if we look up here, the coordinates of this point is 0, 1. Okay, so cos is our x value, so that's 0. So cos of pi on 2 is actually 0. If we looked at the sine of pi on 2 though, remember that sine is our y value, so that means sine of pi on 2 will be 1. Okay, similarly, we could do some others. We could say, well, what's cos of, let's this time say 3 pi on 2. Okay, well, 3 pi on 2, okay, we've gone positive, so we've come all the way around here. So we're down here now. Okay, again, our x value is cos, so again, cos of 3 pi on 2 is also equal to 0. Okay, and sine of 3 pi on 2, okay, it's not 1 this time, but it's negative 1. Okay, we look at a couple of negative angles here, so if we said, well, what's cos of negative pi, that means that we've come around here, and we've got to here. It would actually be the same as if we went positive pi. We're going to get to the same spot, but it's over here. Remember that our cos is our x value, so sine of negative pi is negative 1. Okay, or similarly, that's also equal to cos of pi. Okay, if we look at sine of negative pi, okay, well, that's our y value, so it's going to be 0. Okay, and that's going to be the same for sine of positive pi as well. Okay, so in your early work on sine, cos, and tan, okay, you're going to be finding values, okay, of these points, okay, using these angles. Okay, so hopefully that's enough to get you through this early work on our trig functions. Okay, and stay tuned for some more videos for some later work.